In this practice, we'd like to compare the electric force with the magnetic force acting on two moving protons. But first of all, we'd like to review the magnetic force produced by a moving charge. So we consider the moving charge. Charge of this particle is a Q, and this charged particle moving to the right with a velocity of v. Then this moving charge produces the magnetic field. Field is produced by this moving charge in all the space. But we'd like to consider the magnetic fields produced. We only consider single point in the space of the position vectors of this space is expressed as a r from the moving charge. Then at this point, formed magnetic field is expressed. P is mu naught over 4 pi. Q is the charge of the particles. V is the velocity of the particles cross r over r cube. This cross is a vector product. So this means the magnetic field is perpendicular to the planes formed by the V and R. This V and R. So the vector product is has a two directions directed toward us or toward the board. Then you can use the right hand from V cross R. Then you could find that the direction of the B is directed toward us. This is the magnetic field produced by a moving charge at the point of the R. And the mu naught is a 4 pi times 10 to minus 7 Tesla meter per ampere. This is the mu naught. Then we'd like to compare the electric force with the magnetic force between the two moving charge. So we consider the two protons moving the opposite direction, V, and this is the V. Then at first we'd like to find out the magnetic field produced by these red protons toward the another protons. So this is the position vector of R. Then what kind of the magnetic field produced by the red protons? Magnetic field of B is a mu naught over 4 pi times E is a charge of protons times B cross R over R cube. At this point, B and R is perpendicular with each other. Then magnitude of the B is expressed mu naught over 4 pi times E B R sine 90 degrees over R cube. So 90 degree is 1 and the R is going to be 1 of the R is cancelled out. So the magnitude of the magnetic field is expressed mu naught over 4 pi EV over R square. This is the magnitude of the magnetic field. Then we'd like to find the directions of the magnetic field. You can use the right hand rule from the V cross R. Produce what kind of directions is two choices, toward us or toward the board. So in this case you can use the right hand rule. V cross R. It becomes, this is the direction of the magnetic field. The magnetic field is produced by the red protons on the black protons. Then moving these black protons, actually the Lorentz force, magnetic force acting on these black protons. Then Lorentz force, magnetic force, Lorentz force is expressed. E is a charge over protons, B cross B. Then the directions of the Lorentz force is perpendicular to the velocities of this B and magnetic force B. And then there are two choices, upward or downward, because are perpendicular to these two vectors. Then you can use a right hand rule to discover actually the magnetic force directed upward. This is F sub B, direction of the magnetic force. Okay, then actually the magnitude of the magnetic force is, and again B and magnetic fields, velocity and magnetic fields perpendicular with each other. You can just multiply E, V, B. Okay, then you can substitute this B into these equations. Then you can find the magnetic force is expressed mu naught over 4 pi E squares B squares over R square. Okay, this is the Lorentz force acting on the black protons. And another force is also acting on these protons, because both protons has a charge of the positive charge. So magnetic field's repulsive electric force is acting between the two protons. This is F sub electric force. The magnitude of the electric force is expressed 1 over 4 pi epsilon naught E square over R square. So we have two forces, electric force and magnetic force, acting on the black proton in the same directions. Then we'd like to compare these two forces. When we compare the two forces, we have to create a ratios, as I explained before. So F sub B over F sub E, electric force. Then you can just substitute mu naught over 4 pi E square P square over R squares over electric force 1 over 4 pi epsilon naught E square over R square. Then if you look at the 4 pi appears in the both numerator and the denominators, and the E squares and R square is cancelled out. Then it becomes a really simple form, epsilon naught mu naught V squares. And later we are going to study the expression for the speed of light. Speed of light is a speed of light c. Square of the speed of light is expressed 1 over epsilon naught mu naught. So we are going to study the later these expressions. Then using this expression, this becomes b squares over c squares. All the object, speed of any object is slower than the speed of light. Speed of light is a maximum speed. So this should be the smaller than 1. So if you compare the most left hand side and the right hand side, you can conclude magnetic force is much weaker than the electric force. Okay, so this is the end of this practice.